This is going over Calculus Homework 337, and these are problems 1, 3, 17, 20, 31, 53, and 59. Again, page 337, kind of part 1 from 337. First of all, we've got a problem here. It says, notice we've got an indefinite integral, no limits. There are no limits, so what do we have to put on this one? For any indefinite integral, what do we have to put? When we do the antiderivative, we also have to put, the plus c. Okay, let's just do antiderivative. Hey, what's the antiderivative of cosine of x? What function, when you take its derivative, you just get cosine of x? Yeah, that's sine of x. Okay, good. Okay, how about this one? What's the antiderivative of negative 3x squared? I know it's going to be one higher. Yeah, there it is. That's it. Negative x to the third. Take the derivative of that, and you're going to get negative 3x squared. Take the derivative of that, you're going to get cosine of x. And then, like we said, we got to put a plus c. Okay? Got to put a plus c on any time we have an indefinite integral. Let's go to number 3. Here we go. Problem 3. Okay, hey, same idea. Antiderivative. Okay, hey, let's start. Hey, antiderivative of t squared. Oh, that's got to be t cubed. 3 times what's going to give me 1? Yeah, you got to have a 1/3. Okay, good. Now, in fact, I'll tell you what, before I do anything on this, here's what I'm going to do on this. Should have done this first. I'm going to rewrite this. T squared minus, how do I write this one right here? How do I write that? What's another way to write that? Yeah, that's going to be minus t to the negative 2. Okay? Okay, here we go. Now let's do the antiderivative. Okay. We'll do it right here. Okay, we got the first antiderivative. The antiderivative of t squared is 1/3 t cubed. Now, the antiderivative of this. Okay. Hey, it's going to be t to what power? One number bigger than negative 2. Well, that's negative 1. Okay, negative 1 times what gives me a negative 1? Yeah, just a positive 1. There it is. Hey, what do we have to put? There's no limits on this. There's no limits, so you got to put a plus c. Okay, again, no limits, indefinite integral. There it is. Okay, looking good on number 3. Okay, the next one, 17. Let's go find 17 here. Okay. Okay, here we go. There it is, 17. Now, this is using substitution. Okay, this is using substitution. There's our integral. The first thing over on the right. Over on the right, it says u equals 3 of x. Okay, 3x. First thing, we got to do the du, the derivative of that. Well, what's the derivative of 3x? Just 3. And then I'm going to say dx. Now, I need exactly that. I need exactly that. Now, here's what I'm going to do. I'm just going to rewrite it. Now, I have to have 3 times dx in my integral. I have to have it. Well, that means I got to put it right here. It's got to be 3 times dx. But wait a second. That integral is not equal to the integral I started with. So out at the beginning, out to the left of the integral, what times 3 just gives me 1? Yeah, I got to put a 1/3. There we go. Now, let's do the substitution. In place of the 3dx, what's going? Yeah, right there, the du. Hey, in place of the 3x, what's there? Oh, that's the u. So here it is. This is what it looks like now. 1/3 integral sine of u du. Okay, now take a look. We started with the original integral, and what did we do? We made it simpler. The green one right now is simpler than the one we started. Let's go ahead and do it. We have 1/3. We'll put a bracket. Hey, what's the antiderivative of sine of u? What function, when you take its derivative, you get positive sine of u? Oh, that's negative cosine of u. And then remember, there's no limits. Got to put a plus c. Now we're almost done. The very last step. Notice my original integral right here. My original integral, the variable was x. That's what I want my final integral to be in. So here it is. Let's do it. Let's multiply the 1/3 times this. So I'm going to get negative 1/3 cosine. And now, in place of the u, what does the u equal? What is the u the same as? Yeah, there it is. 3x. Nice. We'll put a plus c. Boom, done. There it is. That's our solution to the indefinite integral. Let's go to 20. Here it is, number 20. Hey, they've got the u. First thing we do, we find the du. The derivative. What's the derivative of 7x? Just 7. What's the derivative negative 2? 0. So I'm going to say the derivative of 7x minus 2, I'm going to say 7 dx. Okay. Now, let me kind of spread this out a little bit. First thing I'm going to do, let's take this 28. See that 28 as a constant? I'm bringing it out front. Integral. Now I've got 7x minus 2 to the third. I'm going to leave myself a little space, and then dx. Now, I have to have 7 times dx. I have to. There's no doubt about it. Well, I got to put it here. I got to have 7 times dx. I got it. But wait a second. That is now not equal to what I started with. Right now, that integral with the 7 dx, that's not equal to the one that I started with. What do I have to multiply the outside by? Yeah, 1/7. Do you see that? You can multiply by 1/7, same as dividing by 7. Okay, now that integral is equal to the integral that I started with. Let's do substitution. Hey, put in place of this. What's going in there? Yeah, du. What's going in place of 7x minus 2? Yeah, that's the u. Okay, here we go. Let's simplify. First of all, what's 28 over 7? Oh, that's 4. Then we got the integral. Then we got u to the third du. Oh, nice. Look back at our original integral. Kind of complicated. Now look at the integral that we're looking at now. Well, I think we could do that. We simplified the integral. That's the idea behind using substitution for doing antiderivatives. Okay, let's go ahead and work on it. Hey, first of all, the 4 bracket. What's the antiderivative of u to the third? Well, it's going to be u to the fourth. Oh, 1/4 u to the fourth. Good. Plus c, because there's no limits. Okay, let's finish it up. Hey, 4 times 1/4, what's that? Oh, that's just 1. I'll put a 1. Now, we don't want to leave it with u. In place of the u, what does the u equal? Yeah, 7x minus 2 raised to the fourth, plus c. There it is. That's number 20 right there. Okay, looking good. Okay. Our next one, what's that, 31? Okay. I'll tell you what, we're going to stop right there. That's the end of part 1 of this page 337. We've got 31, 53, and 59 to go over also.